Alright guys, basically I just want to, I'm looking at the scores from yesterday's quiz, and it seems like a lot of people had a little bit of a hard time with understanding exactly how to solve this problem. Most people got VL correct, and a lot of people got VL correct and VR incorrect. And so I just want to solve the quiz and kind of go over what most people did wrong, so that you guys don't make this mistake in the future. Basically, like I said yesterday in class, when you have a quiz or, any problem for that matter, let me get this cursor right here, any problem that you have with a circuit, you should always start with writing down the things that you know. And first thing that I see here that I know is that 18 milliamps is flowing through this resistor. Okay, so what that tells me, right, this 18 milliamps flowing through this 12K resistor, that tells me the voltage drop across that resistor, so we'll call it V across R3, is equal to 12K times 18 milliamps, right? That's the voltage drop across that resistor. That does not tell me VR, and does not tell me VL, but what it does tell me is it tells me the difference between VR and VL. Okay, so if I multiply those, I'll use my calculator. So it would be 12, so the milli and the K cancel, so it's just 12 times 18, and that gives me 216, right? So what that tells me is that the voltage across R3 is 216 volts, right? So that right now that doesn't tell me VR, and it doesn't tell me VL, but what it does tell me is that VR is greater than VL by 216 volts, right? Or in other words, VL plus 216 volts gives me VR. So we can keep that in mind, but we still don't know VL and we still don't know VR. Okay, so if we want to find VL, what we would do, or one way that we could do this, a lot of you did, is we know that we can combine R1 and R2 in parallel, right? So R1 times R2 over R1 plus R2, or 12K times 12K over 12K plus 12K, and that's going to give me 6K. Basically, I talked about how anytime you have resistors in parallel, if they're equal, then the parallel resistance is equal to just half of whatever that resistor was. So it's, in this case, it's 6K. Sorry, my phone just went off. So basically, we can redraw this circuit. So we would have a 6K resistor here, and then a 12K resistor, and then an 18 milliamp source, current source, right? And so now with this new circuit, this equivalent circuit, we know that this voltage, whatever this voltage is the same as VL, right? So I can figure out now what VL is, because this is an equivalent circuit where I have 18 milliamps flowing down through this 6K. And so a lot of you guys got VL correct. You guys figured out that VL was equal to 18 milliamps times 6 kiloohms. I think it's 108. Yeah, so 108 volts right there. A lot of you guys got that correct, and I think what you guys neglect to realize is that when I just take I times R, I'm still just finding the voltage dropped across that particular resistor. So in this case, I took 18 milliamps times 6K. I know that my current's flowing this way, so I know that this potential up here has to be greater than this potential. And I know that this voltage down here is 0 volts because this is connected to ground. Now, when I take 18 milliamps times 6K, that tells me that the voltage dropped across this resistor is 108 volts, right? But since I know that this is 0, then I know that this is 108 volts, right? Well, what a lot of you guys did in this case was you found this 216 volts at the very beginning, or maybe you found it at the end, and then you said that that was what VR was. You said that VR was equal to 216 volts, neglecting to realize that this voltage that you found here is not the voltage VR. Rather, it's the voltage dropped across R3. Okay? So now we know VL is 108 volts, and we can find VR because VL plus 216 volts is equal to VR. So I plug my VL in, which is 108 plus 216, gives me my VR, and therefore VR is equal to 324 volts. Okay? So now a lot of you guys did get this right, but very many of you guys got it wrong. So VR should be 324 volts, and VL should be 108 volts. And if you put this circuit in LT Spice, you know, for your own satisfaction, here, I'll do it real quick just so we can see. I have the quizzes over here. Quiz 3. Got it in Spice. And let me just run a quick operating point just to prove it to you guys. 324 volts for VR and 108 volts for VL, so that's exactly what we had here. 324 for VR and 108 for VL. So yeah, I just wanted to kind of solve this so that you guys could get a look at a mistake that a lot of you are making. And that mistake is that whenever you calculate the voltage across a resistor, what you are calculating is the voltage that is dropped across that resistor. You're not, when you take V equals IR, right? V equals IR, that applies to a resistor. And what it's telling you, if I have the current flowing here, is that voltage, right? Remember when we do this, if this is V1 and this is V2, this V right here is V1 minus V2, if this is I and this is R. So that's telling me the voltage difference between this voltage and this voltage. It's not telling me the voltage here, it's not telling me the voltage here, it's telling me the difference. And so when we have a resistor connected to ground like we did here, basically this V2 is going to be 0. So we're basically just looking at this voltage. So that's why a lot of you guys got this one correct, because it's super, you know, simple, and you don't really have to think very hard about the voltage drop versus the voltage at a node. So in the case of this 12K resistor, right, we have 18 milliamps flowing through it, we have a 12 kilo ohm resistor, so I multiply those and I get this 216 volts, which is telling me the difference between VR and VL. So in order to find VR, knowing this voltage drop, I would need VL, and in order to find VL, knowing that voltage drop, I would need VR. You don't have either one until you know the drop across the resistor and one or the other. I hope that makes sense to everybody. If you have questions about this, we can talk about it a little bit more in class, but I basically wanted to save class time by making this video real quick and showing you guys how to solve this one. For those of you who come to my office to retake this quiz, I'm going to change the numbers so that you can't just, you know, copy this or just follow exactly what I did with the exact same numbers and memorize the solution. I might just change the current source, change the resistors, but it'll be pretty much the same. Anyways, if anyone has any questions, feel free to send them in the Google group. I'm going to post this right now, and I hope you guys all have a good rest of your Tuesday.